Hi everyone, this is Vivek, and in this particular stream, I have Shubham with me. So Shubham is my ICPC teammate, and today we're gonna solve a very interesting coding test mock. So let me kind of introduce you all to Shubham. Hi Shubham, you're on the stream now. So maybe can you just quickly go ahead and introduce yourself to the audience?
Hey, hello everyone. My name is Shubham Patil. I'm currently working as a software engineer in Google. I graduated from IIT Kharagpur in 2020. I was a batchmate with Vivek. We were also in the same team during our ICPC World Finals 2020. And thanks, Vivek, for inviting me to your channel.
Yep, it's lovely to have you. I think from the time I started my channel, I always thought maybe like when should I kind of invite Shubham on to kind of discussing things over here on the channel. So let's kind of get into the test today, right? So today we'd be solving a little like maybe hard for others, for the audience, but I think since Shubham, you are already a world finalist, I will assume that it's going to be at a moderate level for you. So we'll be solving the test of Directi, which is generally known as a little harder in the industry. And after the stream, I will ask you certain questions on how generally students should like try to attempt the coding test and all, and maybe some general tips and all that we can kind of have for the students that you have seen from your experience of interviewing candidates for interviews, as well as like have seen while guiding students during the journey. So maybe like let's switch on to the stream, like to the coding screen. So this is the test that we'll solve on the practice platform of AlgoZenith. So I will directly, we'll solve the directize test. So maybe I'm going to show you, this is Shubham's screen. So maybe we can scroll to the directize problem set. If you go to D, yeah. So we have, it's above, right? D. So
Yeah.
we have this test over here. So this is the test that we'll attempt. It's a 1 hour test. And like it came up in 2019, but the problems has been repeating quite a lot in different companies. That's what I've seen. So we will kind of solve this one. So I think let's get started, Shubham. So you
Yeah,
can
sure.
start the test and you can keep your like earphones off so that I can explain the things to the audience and you would be able to focus on like just giving the stream. I'll show them your screen once in a while to just discuss what you are doing and what maybe things could have been done better. I think you're already pretty good for that, but again, let's discuss. I'll do that commentary part for myself, right? So let's get started, right?
Okay.
Guys, I think Shubham is starting on. This is a 1 hour test. I've put him on mute so that he can focus on the test. Meanwhile, we will discuss what these questions are. So I think Shubham is reading the first problem uh, over here. So this is directized test. Tests of directi are generally known to be a little harder. But again, since Shubham is world finalist, so I can assume that he can give this test in the given time simulation because I went through the problems already and the problems are a little difficult to be completed in 1 hour by somebody who has not prepared competitive programming, I would say, right? So that's what we'll kind of discuss the problems and I'll explain you the ideas that maybe Shubham is coding and all. So let's see how he performs. So this is absolutely new for even him. So I hope he solves all of them. So let's get started on our end too. So let him read the problem. Till then, like maybe we will go to our screen. So this is a good practice. I think he's kind of seeing what he has understood out of the input, that what he thinks is correct or not. Like, so let me start this. This is my screen now. Let's start the test even on my screen so that we can see the problems and we can actually discuss things. Yep. So I think this is the problem he's reading. Even you can pause the video quickly and maybe read the problem, though I will explain it to you guys, don't worry. Let's quickly like also check what Shubham is doing. I think he's reading problem number 2. Another interesting approach, I suppose, for people who are a little experienced. If you're good at like understanding what is the difficulty level of problems, maybe you should read all the problems very quickly, all the 3 problems, so that maybe if one is hard, you can kind of skip to the some other test, other question in the test, so that you don't get stuck on one problem and you can attempt others, right? So for Shubham, I think he can read problems and he can gauge things very quickly. Okay. From what I have understood, maybe Shubham might find the second problem more trivial than first one. For me, at least the third problem was the hardest out of the 3. And believe me, like any computer programming person would also find it difficult to complete all the 3 problems in the given 1 hour limit that was there for the test. So that's pretty cool. Let's get started with discussing on our end, right? This is my screen now. So I'm going to see which one Shubham's coding so that we will discuss that itself. I think he's going to code second one from what I understand. Okay. This third problem I've seen being asked multiple times in multiple different companies in disguise. Maybe like go to that museum, come back and things like that. Once you read the problem, you'll get the idea. I don't know if Shubham has seen this problem before or not, because this is a very good idea. I'll explain you guys. It's very super interesting. Okay, I think Shubham is going to code the first one. Yeah, nice. So let's discuss the first one while he writes the code for this. Right. So basically, this is saying that given the matrix of matrix A of R rows and C columns, each cell of the matrix is colored either white or black, 0 and 1 standard thing. Now you are given Q queries. You will be given the coordinate of x comma y and an integer k. Right. For each query, you have to find the maximum possible area of a square that has x comma y as a center and contains at most k black cells. Okay. So basically for every query, what you are supposed to do is you have to find the largest square centered at x comma y, right? Like 1 square, 3 by 3, 5 by 5 and so on, that has at most k black cells. Okay. Now, whenever you read this particular problem, let's go to Shubham's stream. And before that, let's look at this like constraints. 1000 cross 1000 standard 1000 cross 1000 matrix. There are 10 to the power 5 queries and each one of us has like pretty big keys. Like all of them can be converted, right? I think maybe 10 to the power 6 would have been sufficient because we can convert all cells in that case. So this is there. This is the constraints. This is the output. And over here, you can see that the largest I can see 0, 1. So 0, 1, 0, 1. Yeah. And then you can convert. So the answer is 1. So basically 0, 1, 0, 1 is this 0 cell. And you cannot convert any black cell into white cell, right? So sorry, any black at most k black cells. So you cannot convert any black cells into white cells. So in this case, the answer is going to be just 1. You can take this white cell, but again, if you try to take 3, it will be too big. So all of them will be blacks and you cannot convert them. So you can see that, of course, these are like 1, 3 square, 9. The area is what is required, right? Maximum possible area of the square, right? Let's take another query where you are getting 25, 2, 2, 10. So 2, 2, 10 is like this particular cell. So I can take this 3 cross 3 rectangle where you have 1, 2, 3, 4, 5, 6, 7 number of ones. So you can convert that because I have limit of 10. But I cannot take 5 cross 5 because I have a bunch of more ones which will make it over the limit of 10. But when I have 20, I can take 5 cross 5 as well. So that's why it's 9 and 25, right? That's what is there. Let's see what Shubham is writing. Okay, so I see he's already written the input and all. So Shubham has a good typing speed. I think he has like, he can code around at 100 words per minute. I think twice of my speed, I guess. But again, that's pretty interesting. So what he's doing is he's basically building sort of a prefix sum array, right? What I see is he's building a prefix sum array so that he can query that in a certain rectangle, how many zeros and ones are there, right? How many black cells are there that he'll have to convert. And then for every query, he's given an X and Y. He will kind of try and do a binary search on what is the low and high, the diameter or the length maybe. Let's see what he writes. Yeah, I think he's going to convert it to a binary search of so he's basically taking the length of half of the length of the square. So from the center minus mid plus mid and downwards plus mid minus mid, right? So that's the thing. So let me explain this on my computer a little bit so that you guys can follow along what he's doing. So the idea that he's using, right, is basically this, that you have this grid, right? And you are given a center x comma y. So what he's doing is he's trying to do the binary search on the, like, how much length over here, like the x over, I not say x. Let's suppose he's binary searching on the value p such that this particular square has like less than equal to k1s, right? So prefix sums, 2D prefix sum is a technique that can help you to kind of get this idea that how do you get the number of ones in any rectangle in O of 1. So So once you pre-compute prefix sum, you can get that in O of 1. So he will be able to get the number of ones in over here, and then there will be a certain point, like you can always make 1, you can make 3, you can make 5, but then maybe like when you try to get a 7x7 size, the number of ones gets too large, so you cannot convert it, right? And in that case, what will happen is it will like the binary search will return false. So the way we learn binary search is we have like till a certain point things are true, after that it becomes false. So we want to find the last point where it's true, right? The last, how much you can do, the best you can do. So that's what we do in binary search. I think let's go back to Shubham's screen. I'm going to explain it over there itself. So he had found the coordinates of the top right bottom most corners, and then from over here, if he's, so he has written comments, that's really good, though it's not required I think in coding test. So if the square goes out of the board, then it's an invalid cell, so it's not possible that big of a mid. And then what he's doing is he's finding out the prefix. If either of the two coordinates go out of the board, then that's invalid. And what he's doing next is finding out the number of ones in the rectangle that he is building right now, right? Okay, so this is the standard code of prefix sum. So there is this, so I will link down a quick list of playlists that you can watch, and you will be absolutely good at prefix sum, be that 1D, 2D, even advanced variations like AP-GP on prefix sum. I will link that particular link. It's freely available on Algorithm platform. You can watch that and you will be super good at AP, like prefix sums in particular, right? So yeah, he's doing, for the query, he's finding out an answer. He's keeping an answer variable. He will do a binary search. Yeah, that's how generally binary search is written. You can have answer as 0 because let's say you cannot convert anything and the cell at the center has like a black cell. So you will have answer as 0, right? Okay, he has written a lot of codes already. I don't think people will be able to write this quick code unless they have like kind of seen something before. I suppose when you are at a world finance level, you do see such problems before too. So I would assume that he should be able to code it pretty fast. So he's finding the length. Yeah, his code is correct. He's finding the length. It should be the area of the thing. That he has to find the area of this. So what he has found out is like if this is the cell, let's suppose this is 5, right? The best answer was 5. So he found out that this length should be 3. So what he's writing is 2 into answer minus 1 whole square. So this, if this is 3, the length over here is 2 into 3 minus 1, right? That's what he's finding out. And then square of that is the area of this rectangle, this square. So that's what he's doing over here. Let's see. Yeah, seems correct to me. So he has handled 0 case. Yeah, that's really nice. I think this code seems correct. I don't know if the area will ever overflow. It will not, because the maximum area you can go is 10 to the power 6. So even everything is in 8. So that should suffice. Yeah, so he's double checking the code. So what I've seen in coding test is like if you make a submission and it's wrong on all test cases, then you get a penalty. If it's correct on some test cases, then you don't generally get a penalty. So that's something you can keep in mind. Like when you are giving a coding test, don't submit a code that you think might give wrong answers on all test cases, right? If you want to make a submission, just make sure that it at least passes the sample and all, right? Never make a submission that fails on everything, at least on the main test case also. If you're getting some partial score, that's not counted as penalty. But when you submit something that fails on all test cases, then that's counted as a penalty. And that's something that can get you rank later in the coding tests and you might not get shortlisted, right? So he has submitted the problem. That's pretty cool. I think it's going to take some time. And he's pretty fast at switching the problems. He doesn't wait for his submissions to get accepted. That's typical Shubham. He is very confident in his solution, I suppose. So even you should not wait on submissions, right? It takes 30 seconds at times. Why to waste that 30 seconds when you can spend reading the problem, right? Okay, still in queue. Okay, let's go to so he's reading the second problem. I think he has already read it, but again, I think he's reading this one. He wants to be double sure that his code is correct. Let's focus on writing that. Okay, so I'll explain the second problem. That's also I think a standard problem for Shubham, if I'm not wrong, because like at least I have solved similar questions before, and anybody who has solved like topic questions of that would have solved that problem. So let's move to the second problem. And that's 7 minutes, and he has solved already a problem. That's pretty cool. That's how you do when you're a like good competitive programmer. That's how you perform in interviews and in coding tests. So I would definitely say like it's a big plus if you are really good at this. Basically, what you're given is you're given a tree, and what is happening in queries, you are going to delete integer j, or you will be given an integer j, and you have to remove the jth number edge from the tree. So there is bunch of edges given to you. There are edges numbered 1 to a-1, and in each query you will be given a j, and you have to delete that edge. After deleting, you have to tell me what is the maximum size among all of this trees that are creating. So what is happening over here? Let's go to the drawing board. Let's suppose there is a tree like this. Some tree structure is happening over here. So in each query, you might be told to delete this particular edge. Now tell me what is the biggest tree available. So there is one tree over here, one tree over here. Biggest one is 4. Then what might happen is you might also get another thing, which is you might get, okay, now delete this particular one, or let's say delete this particular one. So you now have 1, 2, 3. So the largest size is still, sorry, this earliest size was 5. This size will be 4, and then you might delete this particular. So now the size is equal to 3, and this is how you do it. So you are deleting edges one by one, and then you have to find the largest size component or largest size tree in such cases, right? Okay. I suppose Subham is reading back this code, so most probably he might have got a wrong answer. Cool, I think he will handle it up, don't worry. Let's see how he debugs his code. And it's fine if you get a wrong answer in coding test. I think that's not a big penalty as such. Okay, so he makes the low as 1 now, which makes sense because he's trying, if low is ever 0, I think he will get some issues with his accessing of indexes and all. Let's see if he gets an accepted on that or not. Believe me, coding test on a stream is a different kind of pressure, and this is what you feel when you actually go for a test in an actual company's round, because you have a lot of pressure in mind, right? That hey, I have to get selected in the company and other things. So much of pressure. Oh, so he got his actors at night. Nice. Let's go to the next thing. So this is how you quickly debug. You just found out what's the mistake just by looking at code. This is I think the biggest plus of a competitive program. It's not about learning more things. Everybody can solve those standard questions and other things, but finding bugs in stress scenarios is the biggest power of competitive programmers. Okay, so he's taking up edges. So what is going to be the strategy? I'm going to like wait for him to code something, and then I'll explain you. I think what he's going to use is something called as union find. There is a very interesting playlist that I've created on the channel on union find. You will learn 4 different levels. There is 4 different levels, and you will learn all different ideas that exist in union finds. This is actually one of the very standard problems of union find, where you will have to reverse the queries. So in union find, you can add edges. So what will we do is we will first break all the edges that are broken, build the components, and then merge the edges back. That's how you would solve this problem, I suppose. So he is kind of maintaining marked. I'll have to see what he's doing. There are more ideas too. You can actually do something like small to large merge kind of thing, where you actually go ahead and color everything in a smaller component, and that's still going to be n log n kind of thing. But union find is the best solution, I suppose, for this one. Okay, so he's taking which all queries will be deleted. So he's maintaining the queries, ith queries of deleting edge u and which are the edges that are being deleted. So he's maintaining that in marked array and the queries array, right? I think I'm speaking too much while commenting about his code. It's so easy to comment, but like actually sitting there and coding the things is not so easy. Did you see how swiftly he converted back to a vector and all? I think he realized that it's actually a problem with test cases, so he will have to clear things up over here. So he's writing basically a union find. In union find, you have a root node, what is the root when you start from this node? And then you maintain the size, yeah, basically parent array, right? So when you add a particular edge, you merge things based on rank, and then you have to find the root of a particular node. When you keep following the parent, where do you reach? If two things lead to the same thing, then they are in the same component, right? That's what union finds kind of do. If parent of u is equal to u, so that's the base case, return u, or else I think return. Yeah, so this is basically path compression right over there. So you find the parent of u, the root of the parent of u, and then you directly link this to that node. So this is called path compression. I've made extensive video on discussing all these ideas. And I think in merge, he's going to use rank compression as well. So he's finding the root for both the node and he will merge the two roots, right? I think this is never going to happen. When are we going to merge two nodes which are already merged? It's a tree, so it will never happen. You could have not coded that as well, but fine. That's the general purpose. I think, he's writing the general purpose union find for this. This one looks so serious. Okay, so size of R1, R2. So whichever size is bigger, he will make the smaller one link to the larger one. This is called rank compression, right? So the other one was called path of u equal to root of that. When you do this compression, it's called path compression. This is called rank compression. If you use both of them, there is a time complexity of Ackermann function. So this is the theory of union find. I've made an extensive playlist on this. Make sure that you go ahead and watch that up. Okay, seems like an interesting idea. So let's watch him write a few more pieces of code. You can swap them, right? If this is less than, if R1 is less, then swap R1, R2. That's what he's going to do. Nice. So it always makes sure that R1 is the bigger one. So he makes the parent of R2 as R1, and then parent, yeah, this should be, I think, yeah, this needs to be swapped. Correct. So Shivam, I have faith on Shivam. He'll be able to debug all these things very quickly. Pick up these skills. I think this is what you learn over time. So since there are test cases, you will need to clear the global structures, right? That's another problem when you have test cases. So you have to make sure that you clear the global things correctly and set their sizes correctly. This is something that I think people don't learn when they solve problems on lead code. That when you keep global, when you have to share things across test cases, how do you do that? This is something that you should learn ideally. Because I have seen people struggling to do these things on coding tests when they know the logic, right? The same problem, let's say, on some lead code comes up, and then you are unable to code it just because you don't know how to make things global, how to share it across test cases. That's going to be a very bad scenario. So learn these things very quickly. Okay, so he's going to go through, I suppose, all the edges which are not marked. He will go through all the edges and he will add them into the already built union find, and he's going to then process the queries in the reverse order. I suppose that whatever is removed last will be added first so that you get to the state. So let me go ahead and explain you what he is doing a little bit. So let's suppose the edges that are not deleted are, let's say, this, right? Then there is another state where you had removed this edge. So before this, the scenario was something like this. And before this, the scenario was maybe something like this. Okay. So when you delete this, you go to this. When you delete this, you go to this. Okay. What he is doing is he has marked which all will be deleted and he has added the rest. So he is over here. And now he will find in union find what is the largest size. And then he will add back this edge. In union find, you can do this very neatly. And this is a new potential size that is possible. Okay. Then he will add back this edge and he will go to this. So adding in union find is possible. Reversal is not possible. So this is what he's doing over here. Let's go back to his screen. So he's merging back things. Answer is equal to this. He's going to the queries in the reverse order. That's very interesting. As I said, he's finding out the edge that will be deleted in that step, and he's adding it back so that he gets to the point where it's before that. So he's maintaining a max size, which is 1. I have to see what he's written in the merge code. I suppose he's maintaining the max size in the merge code. Okay, that's too fast for us to comprehend. I think he's waiting on some test case. He has not taken test cases, I suppose. I'm not sure. It's so interesting to see a world finalist coding, right? I mean, we both are world finalists, but again, I think if when it comes to coding things faster, Shubham has a big advantage of high typing speed. I also have an advantage. I sometimes write shorter codes, though I cannot write shorter than this for this problem. Okay. He has not taken test cases, I suppose. Is then everything correct? He has maintained the max size in his merge. Whenever you are merging two things, the new size is the possible max value. So he's maintaining that max component size. Merging it up. I think he will print and then see that okay, test cases are not being registered. That's what is going to happen. Oh, he has taken test cases. Then why is it not working? Now even I'm not sure what's the mistake. Let him figure it out. He'll print things where is the code kind of going into infinite loop. He has not set the parents by default. Parents by default are, what is the default value of parents? Okay, parents of I is I, that's fine. It's correct to me. We'll add some certain prints and see. Okay, he's running one by one test cases. That's interesting. But I suppose the first one itself will not work because it's already giving, like it's running for a long time. Okay, so it's going into infinite loop. So he will print where is it stopping? N minus 1 edges. Yeah, it seems his code is correct. Even I'm not sure what is going wrong. Oh, you're seeing, okay, this is how you debug basically, right? See whether the code is running till this point or not. And you see whether the merge function is kind of exiting, because whether you're going into an infinite loop in merge, I don't think he's going to go into infinite loop in merge. Okay, so it's not even printing here. I suppose tries whether fast try is not going to be a problem. Okay, let's see how he debugs in stress. Remember, he's a world finalist, so he can do this fast. When you will be in stress and when you will have to kind of give the mock coding down, this is going to be difficult. Isn't it so interesting to watch him? Guys, you will have to code like this also. So one other thing, like when you use the fast IO, unless you do endl, it doesn't flushes things to the stream. So you don't see the output of here and other things. Okay, I think he's messing up somewhere in the parent function. Why is it not even printing? Oh, the file name was b.cpp. That's sad. Yeah, that's correct. He just make it on the single line. So these are things that you mess around even in contests sometimes. Wrong file, running the wrong file. Yeah, I think that's correct. He will just idly submit, I suppose. Testing one final time. Working fine. And here we go with the submission. So once he scrolls up, let's see how much time he has left. He has 30 minutes left. That's too fast. Two problems in 30 minutes, 15 minutes each. That is like ideally what I would say is like 20 minutes each problem is something that you will get ideally in such tests, mostly harder tests, right? And see if you mess up somewhere in coding. As Shubham read the problem very fast, he already knew this logic. I mean, this is a pretty standard logic in union find, so he already knew this logic, so it was very fast for him. But if you have to think about it and solve it in the test, it will be super difficult for you. So make sure that you practice more and more questions, right? Practicing such questions becomes super important. I'm going to quickly talk about the platform too. So this is the practice.algorithmic platform, which contains real questions of all the tests, all the companies that has happened in the last few years. I think within the next week, you will also have 75 more tests being added over here. So if you want to get a quick subscription for this for the next 3 months to practice for coding tests and interviews, coding tests of different companies that is going to happen on campus and off campus test, make sure that you get the subscription for it. I think there is a 50% discount link in the comment in the description below. Make sure that you give one test every day so that you are in a regular practice in a timed manner, that you can solve the question in a timed setup, because it's super difficult to solve things in a timed fashion because you will have the pressure of time. It's not like a practice question where you can spend one day fully, right? So that's about the platform. We'll come back over here, and I think Shubham is doing the last problem. So I think I've already explained the second problem. Let's kind of move to the last problem and read the problem on our screen, right? Let's move to the last one. So this is basically a very interesting question. You have a shadowland of beautiful city and museums connected with bidirectional roads. There is a cost of traveling each road. So every edge is like a weighted edge. It's a graph problem, obviously. However, there's an additional cost one has to pay if he decides to enter the museum. That's interesting. Okay. The cost of entering the museum need not be same for every node. So for each museum, he wants to know the minimum total amount he has to pay if he starts his journey in front of Ayat Museum and enters any one of the museum. So what is being asked over here is you will start at any particular place and you will have to find out whichever museum. You can go to any museum, but from every starting node, find out minimum cost in which you can visit any one of the museums. Okay. And the note over here that you have to find out for each museum for every eye. And that's super interesting because you cannot really just do it every time for eye. Let's go to the constraint. So let's go to the notes too. Abhishek may or may not enter the same museum he is starting from, because he can. What might happen is that wherever you are starting, the cost of entry to that museum is very high. So you might travel an edge, go there and go to that particular museum, or you might travel one edge, another edge, and then go to that museum. So there are a bunch of options available to you, right? The graph may or may not be fully connected, which means like there can be components here and there, right? There may be multiple roads between same pair of museums. That's interesting, which means you should ideally take the minimum one. That's what you will use, but that has to be handled in the code. There may be roads which connect the museum to itself. So there are self loops available in the graph, which are of no use. So you can discard them as you code, right? While traveling the road, he will not enter any museum that he encounters on his way till he finally enters the museum, such that total cost of journey is minimized. So it's like when he's like travel. So let's suppose A, then he goes to B, then he goes to C, and then enters the museum at C. So he will not enter the museum at B for sure. So there will be cost of H, and then the museum enter cost at C. That's what it's being said, right? So let's print the array where ith element represents the minimum cost to visit the ith museum. So let's try to take a sample case and try to dry run this on our end. I think let's see what Shubham is doing. He's reading the inputs once. So he's I think drawing the graph for the input. This is another interesting thing. Definitely draw the graphs for the inputs that is given so that you are clear on the picture. This is what I have to do, right? Let's come back. Let's come back to our stream and let's go to the drawing pad and let's see this problem, right? So basically, let's try to see. Let's see there is an, I'm going to number them 1, 2, 3, right? These edges cost, let's suppose 5, this edge cost 7, this edge cost 10, right? And there is this museum. To enter this museum costs 100. To enter this museum costs 50. To enter this museum, it costs 2. To enter this museum, this is node number 4. This is node number 3. I'm going to write the node numbers inside the circle so that it's clear on that. Okay. So this is going to cost, let's suppose, to enter this museum, it's going to cost 10. And then to enter this museum, it's going to cost 2 rupees. That's very, very cheap, right? So if this is the case, then let's suppose if you start over here, it's obviously not optimal to go to this museum because it will cost you 100 rupees to enter that museum. Maybe what you will do is you will go over here and then go over here and then enter this museum because it will cost you 5 plus 10 to travel to this, and then entry cost is pretty cheap. So you will do it in 5 plus 10, 15 plus 2, 17 rupees, right? If you start, let's say over here, you will directly go over here and enter, right? If you start over here, maybe it's pretty optimal to just enter this museum itself because it will cost you 10. But if you try to go somewhere else, it will cost you more than that. So if you start at 3, you will enter at 3 itself and the cost will be 10. At 2, if you start, so for 1, this will be there. For 3, it will be 10 cost only. For 2, you would obviously want to travel to this because 50 is also pretty high cost. So you would go to this node. It will cost you like 10 plus 2, 12, right? For 4, you will obviously enter there directly. So this is the values that you will get for each of the values. So you should print 17, then 2, 12, then 10, then 2, something like this, right? That's what has to be done. Oh, I see Subham has already started coding. Let's see his screen now. Okay, so that's the style. So what should we do over here? This is a very interesting problem. I'll explain you once Shubham starts writing certain ideas. So I will explain whatever idea he codes, right? I suppose he will write something similar to Dijkstra over here. This is a very interesting problem. I think if you have not seen this idea before, it's a little difficult. I remember I had seen this in one of Code Nation's test also. This was the same problem that was asked like 2 years back in one of the Code Nation, and this came in placement test 3 years back in a Directi company. The same basically, right? So companies' questions do get repeated. I'm repeating that again and again. Okay. So over here, he is building the graph, simple weighted graph kind of a code, right? I mean, we all should agree that I think Shubham writes pretty clean code. It's super difficult to write these clean codes on our own end. I don't write this clean code in my tests, but he also writes like this only in practice too. I've seen his code. I'm his teammate after all, right? Super. Okay, Shubham is a little low on time, I suppose. So this was a super hard test. Like solving this problem in 20 minutes is difficult. So he's taking the entry cost. This is only this. Let's try to see how he code this problem. So maybe I can try you and explain how you can do this problem a little bit till he writes some code. Okay. So the way I think about this problem is this is more of a problem of a Dijkstra, but it's not so simple to see how would you find out the closest one, right? So the way I see it is it's better to expand the museums rather than the sources. What did I just say? Okay. So in Dijkstra, what happens, right? You basically start from a certain nodes and then you try to find out what is the start, go to the target and find the shortest path. But then every node will have different shortest path to different targets that are available, right? So you will have to do n into n log n Dijkstra. There's a Dijkstra shortest path involved for sure. So, but there will be some n log n into every node n kind of a factor. What over here you can do is you can do multi-source Dijkstra from every museum, so that it will, every museum will expand to the closest node that it can go to, and for every node you will know which museum to connect to. Basically what you do over here is you have, let's suppose, bunch of museums available over here. So what you can do is you can create a super node over here, right? And you can connect this with 100 cost. Okay, you can connect this with 50 cost, you can connect this with 10 cost, you can connect this with sorry, not 10 cost, 10 cost, and this with 2 cost. And then you can run Dijkstra from this particular node. Run Dijkstra. What will happen? It will take the shortest path first, this one. Okay, then it will take the next shortest path. This 10 is pretty short, so it will take this edge. Then the next shortest path is this 10, so this will have a distance of 12, this will have a distance of 2, this will have a distance of 10. And then the next shortest path that you can relax is this edge, so it will get a shortest path of 17. So if you run Dijkstra from this node, do you see that you get actually the shortest path to every other node? That's super interesting, because if you just run a simple Dijkstra from all the museums, you get the shortest path to all the nodes from any of the museums. This is what happens. So whenever you have to solve this problem, minimum of distance to, like, from any source to a particular I, okay, minimum of distance of every, let me write it properly, distance of a source, ith source, to x, some node x, right? You want to find across all different source. Okay, some k number of sources are there, so you have to find the distance from I to any x for all different sources. If you ever get this expression, it's a problem of multi-source shortest path. Okay, and in such cases what you do is, if you are using BFS, if you are using Dijkstra, if you are, sorry, not, yeah, basically BFS, you put all the sources together in the queue, in the priority queue and all, and then you just run that Dijkstra, you run that, so it will find the shortest path to whichever source is the closest to any node. Okay, that's what this Dijkstra or BFS code does. Multi-source shortest path is a very interesting idea that exists, right? So that's what is this this problem is asking for. And I think let's go to Shubham's code. I think he would be writing very similar thing. What he's doing, he's inserting, he's writing Dijkstra, right? Okay, so he has inserted the negative of distance node, and it's pretty some standard to him now. So direct Dijkstra problem. Okay, I very recently saw that the same question with just a small twist, that you have to come back to the original node also, like you have to go to a museum, visit, and then come back. So just make the edges twice the weight that is given. That was the trick for that problem. But the same test came up in another company's test very recently. Okay. So at algorithms, we basically keep preparing students on the test questions that keeps coming up. That's always has to be there, because you have to be relevant with what is being asked in different companies, because questions repeat across things, right? Nobody can create new questions every test. Nobody can, no problem setter can do that. There are so many students sitting for test, much more than how many questions we can ever create. Okay, so he's looking at the cases. He has 18 minutes. He will, I think, be able to solve it now. He has already written the code. Did you see it took him like 4 or 5 minutes just to code all of this? Okay, I think he has not taken test cases, maybe. Yeah, he has done it. Right, simple mistakes. Yeah, that's pretty much correct. Quick check before you submit. That's really interesting. The distance can be long. That's neat. So basically, when you keep negative of distance comma u, the priority queue by default will put the shortest path. The negative one will become the largest. So shortest path we need to expand. That's the idea of Dijkstra, right? So you put negative of distance comma u, and then the largest one will be the smallest value in negative version. So Dijkstra, the priority queue inbuilt in C++ can do that now, right? Okay, so he has submitted the third problem. Let's see if he gets an AC. I think this code is correct. Suppose he will get an AC on this one. Okay. So what I've seen is sometimes it takes around 30 seconds to kind of evaluate any submission on any platform in general. And like basically what happens, yeah, so he got accepted on this. And he can end the test. Okay, I think he has accepted all of them. So that's shown for you, quickly completing a hard test in 40 minutes. Yeah, so he scored 300 out of 300. That's pretty nice. Okay, I think let's get back him on the stream and we will talk to him directly. So he can plug in back the earphones and stuff, and then we'll talk to him. So Shubham, are you back on the stream?
Yeah.
Yep, you're clearly audible. So how was the test? What did you think about the test? So let's quickly ask you a few questions. So how much would you rate the difficulty of this test out of 1 out of 5?
Yeah, the test was difficult.
Yes, I think for you, like since you have a little good typing speed and like you have solved a lot of problems on these topics, it's a little simpler. But think about somebody like who is, let's say, even 1600, 1700. I think for them, even them, the test would be pretty hard, like to complete in 60 minutes. And with one wrong answer, I think it's very difficult to kind of get it in time, right?
Yeah, especially like the second question they ask on the question was on union find. So you should know the code, like the exact snippet, like how to code the union find.
Yep. And I think you should have also seen the reversal technique once before, like you reverse
Yeah,
the queries one before. Like without that, it's super difficult to kind of code it on the spot, right?
yeah.
So
I
that's
mean,
it.
I think compared to a normal test, if anyone can solve two questions, I think it's a pretty good
Got
score.
it. Cool. So what would be the hardest problem out of the three? What do you think?
I would say the third one.
Third one, right? Because I think it's sort of like multi-source Dijkstra, and like unless you have seen something before, even like coming from the problem to the multi-source version is a little difficult, right? I mean, even realizing it's actually multi-source problem is like pretty difficult to see.
Yeah, you are right. But so actually, I use this kind of trick. So whenever I see that problem asking for uh, like query on a multiple things, and so I just reverse the things. So here what I did, I just realized that we can solve this problem with multi-source Dijkstra. But what I did, I created one pseudo node and connected the edge. So yeah, but this could be solved in multi-source as well.
Got it. Um, okay. So Shubham, I think like the stream is lagging a little bit. What we can do is we can remove the stop. You can stop sharing the screen, and then we can continue back with the next question.
Sure.
Okay. So I think so. So my next question would be to you, like, would be for general audience, like who are watching this particular video. What do you think somebody like? What should be the correct approach of attempting a coding test, or what do you think? What would be some tips from you on how they can kind of give coding tests in a better way? Because I think coding tests, like people think interviews are the only thing that matters, but again, to get to that level, you have to cross the coding test. So, what are some of the pointers that you generally keep in mind, or what you would suggest the audience to kind of follow to have a better, like, kind of attempt at a coding test?
Um, so I would say first start with reading all the problems. So I read the first problem, then I read the second problem, and when I just look into the third problem, I got to know that it's a difficult test. Okay, but it may not be necessary. Like in some coding tests, the order might be wrong. I mean, the easy question could be at the last position. So it's very important to read all the questions first. And once you read the question, you will get a pretty like a rough idea like on which topic this question is on. And if you think it's on easy topic, or if it's just a sorting base or some min max base, which you can code in just 1 or 2 minutes, something like that. So you can code that question first. So the first advice from me is to first read all the questions and start submitting the easiest one first. The next thing is I would say look at the constraints. So you like there could be a solution like let's talk about this test only. So here in the third question we need to use long int because I was looking into if there is any module or something like that, but it was not mentioned in the problem. So I was sure that okay, I need to use long int, and this is a very common mistake. Like if we use int and it gets overflow, so even if a solution is correct, we get wrong answer, and it's pretty tempting to see such wrong answer. Like yeah, so the first like so look at the constraints. Second thing, I would say whenever we use global variables, make sure that we clear them after each test case. Like in the test only, the second problem, I think there was multiple test case, and I was using some global variables. So so I was kind of forgetting like okay, I need to clear them all. But it's very important to clear all the global variables before proceeding to the next test case. Otherwise, it will get reused and you will get wrong answer.
Correct.
And there is one more thing I noticed in the test is that look at it, we need to read a problem statement correctly. If we read the problem statement wrong and if we like the worst case will be if we misunderstood the problem. Okay, and so it will be a waste of time. So read the problem statement carefully and look at all the small details. Like in the third question of this test, it was the graph, and they have the all the like they mention clearly like it has a self loop and all. So make sure that your code is working on those kind of edge cases. So you need to read a problem statement very carefully, and and also one more thing we need to make sure that like sometimes the statement might not be clear just reading it. So look at the sample examples as well. So so in this context only in the first question it was saying that okay find a square, but it was not clear if it can be even length. Okay, so when I look into the samples I got to know okay it has to be an odd length square. So 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 it's important like to go through the samples once so that it will also build your understanding and you won't make a mistake of misunderstanding the problem.
Correct. I mean, even if you have a wrong logic, if you just check, even in the third problem, let's suppose you have thought something else, and then you just run it on the sample, you will see, that the numbers are a little different. So you will quickly understand,
Yeah,
that there is some wrong logic that you have thought right now. Correct.
yeah,
Correct. And I think in tests like this, if you read a problem wrong and then attempt it, I don't think there is any chance that you can complete all three problems for sure,
yeah,
unless you're super fast. I mean, for you it's different, but I think for normal people, like it's super difficult to kind of code all three problems anyways. And then if you make a mistake and then you are spending too much time in like redoing a problem, then I think it's super hard to do that, right? Yeah, I think it was a pretty good learning experience for everyone. I think I kind of also enjoyed explaining everything, the solution ideas and your code at all time. So it was lovely having you, Shubham, on the stream. Any last words to the audience that we have on the stream, on the like video right now, they are, who are watching and who are looking forward to any like last words that you have?
So yeah, I would say just stay focused, okay? Don't get panic and stay calm and practice a lot. So practice is everything. The more you practice, the more better you'll get. So yeah, so best of luck, all of you.
Yep. So that's I guess all for this particular video. Thanks for joining in, guys. That will be there. You have a bunch of links in the description. Make sure that you check them out. And what we'll do is we'll have another such stream with more people. If you want to be part of these streams where we have invite more audiences and kind of have a mock test for them conducted out, so you can fill out the form that is also there in the description, the first link, and you will be invited on a random basis, right? So see you in another next stream. Bye bye, and have a great day.